While there are several variations of the GED Smart Linear Extruder, they all basically do the same thing. They apply sealant and matrix materials to the intercept spacer frame. Here we will learn what to look for and how to measure the sealant. The extruder applies sealant to the sides of the spacer for the primary seal, and to the bottom or back of the spacer. The side and bottom sealant may be the same material, or they may be different depending upon the type of extruder being used. Regardless, the function of the primary or side seal is the same. It's the material that holds the glass to the spacer. It provides a barrier to keep moisture out of the IG unit, and it retains the inert gas that is often put into the unit to help improve its thermal dynamics. The bottom sealant is there to protect the spacer, improve thermal performance, and in some cases to provide a secondary seal. So how much material should be applied to the spacer? This is something that is determined between your company, the customer, and the sealant manufacturer. Generally, you want to provide enough material to provide an adequate seal for the unit's expected lifetime. To further answer this question, let's look at the units after they've been heated and pressed. There are two dimensions that are critical to the integrity of the IG unit: the wet out and the material thickness between the spacer and the glass. The wet out is how wide the material is pressed out between the glass and the spacer, against the bearing surface of the spacer. This width, not including the bottom sealant, should be a minimum of 3/16 of an inch or 187 thousandths wide, which forms the unit's MVT path. That is, its moisture vapor transmittance path. The wider this path, the less chance of moisture entering the unit and causing a failure. Most processes will target a 1/4 inch wet out, but the more you cover of the spacer's 300 thousandths profile, the better the MVT. The other dimension is the thickness of the material between the spacer and the glass. This should be a minimum of 15 thousandths to 25 thousandths. Variation in the spacer form, glass thickness, oven temperature, and overall IG unit thickness can affect this slightly. So back to the extruder. You need to apply enough material to achieve these wet out dimensions, assuming that the oven and the press are properly set. Typically, the side seal thickness should measure approximately 50 to 60 thousandths, with a full profile bead. Ideally, the material should be sufficient to fill the bead channel of the nozzle tip, and any excess should create a thin layer of material above and below the bead on the side of the spacer. Sealant can be difficult to measure accurately because the material is soft. Holding a pair of calipers that are open slightly, place a finger over the depth probe and apply slight pressure. Drag the tip of the probe down from the top of the bead, placing the end of the caliper over top of the bead. Hold the caliper squarely to the side of the spacer in all directions. The slightest angle will result in an inaccurate measurement. Make sure the end of the caliper is directly over the bead. Do not look at the caliper's display, but rather at the probe end. Focusing on the light between the end of the calipers and the bead, slowly slide the calipers down until the light disappears between the bead and the base of the caliper. Without moving the calipers, glance over to the display and take a reading. Try this several times in the midsection of the spacer, keeping several inches away from the corners and mutton punches. When done properly, your readings should be consistent within a few thousandths of an inch. Check the opposite side of the spacer in the same manner. Both sides should be nearly equal and provide enough material for proper wet out. The bottom sealant should measure between 30 to 50 thousandths. Holding the calipers in the same way, press the probe into the bottom sealant and wiggle it around so that the probe is against the bare metal. Holding the calipers perpendicular to the bottom of the spacer in all directions, slide the end of the caliper down until there is no light between it and the bottom sealant. Without moving the calipers, glance at the display and take a reading. Measure the bottom sealant several times to verify your consistency in taking readings. The sealant application should be checked at least once per shift.